everyone. So in this video, we're going to be speaking about forms of energy. Now, we talk about energy a lot when we're doing energy efficiency, because what's happening in energy efficiency is we're looking at how efficient a particular electric device is at taking the electricity that's coming into it and changing forms. So for instance, a light bulb changes electrical energy to luminous energy. A speaker changes electrical energy to sound waves energy, so sound energy. So to be able to do energy efficiency questions, a lot of the time they pose you what are the changes of energy that happen. So it's really important to talk about our different forms of energy. Now, energy is the ability to do work. So when we're talking about work, we're basically the ability for change to occur. And this sounds extremely, I guess, broad, because energy in itself is the mechanism that allows things to happen. Now, there are multiple forms of energy, and we can basically subdivide them into two main groups. And these groups are potential energy and kinetic energy. Now, when we're talking about potential energy, we're talking about energy that is stored. So and just like the word says, the potential meaning the possibility of something to happen. So potential energy is any energy that is stored within the object. So examples, and we're going to be talking about them in a lot more detail: chemical, nuclear, elastic, all of these are forms of potential energy because it's stored ability. It's not being used at the moment, but it's stored within the object. When we're talking about kinetic energy, we're talking about energy of objects in motion. So any form of energy that is moving, so light waves, sound waves, wind. There are multiple different examples of kinetic energy because the key thing in kinetic energy is motion. So what we're going to do is we're going to go through the different forms in a little bit of detail. So our first key form of potential energy is chemical. So when we're talking about chemical energy, we're talking about energy that is stored within chemical bonds. And what happens is that when you have a chemical reaction, so during a reaction, this energy gets released. And it can either be released as heat, as light, as sound, but anything. So any time that we have a chemical reaction, we are changing that chemical energy, so the energy that's saved within the chemical bonds, and either forming new chemical bonds, producing light, producing heat. So for seeing right here, this is actually an example of a combustion reaction. And what's happening is my cute little gummy bear is basically going to produce an exothermic combustion reaction where I'm releasing heat and light. And all of the energy that allows for this to happen was stored within the chemical bonds of our gummy bear. So chemical energy is a form of potential energy. Another example of potential energy would be nuclear energy. So when we're looking at nuclear energy, we're talking about energy that is stored within the nuclei of atoms. And the only time that this energy is released is when I have one of my two types of nuclear reactions. So fission or fusion. So this image right here is looking at fission. And when I'm talking about nuclear fission, I'm basically splitting a relatively large atom into lighter elements. And during this reaction, because I am breaking apart the nucleus of the atom, I release not only neutrons and lighter elements, but a lot of energy. And in nuclear reactors, they tap this energy to produce electricity because this energy is usually in the form of heat. And then they tap it and they can produce that into electricity. Fusion is not when I'm splitting the atom, but I'm actually fusing two smaller atoms. So fusion, a typical example of where fusion happens is actually in stars. So if we're looking at the sun is basically a big ball of nuclear reactor where it's taking hydrogen atoms and they're fusing together to produce helium and other heavier elements. Our next example of potential energy is elastic energy. And elastic energy is energy that is stored in springs and/or elastic material. So a key example of an object that has elastic energy would be a spring. So if I'm looking at our image over here, when I am stretching or compressing the spring, I'm actually getting potential energy in the object. And the moment I let go, the spring goes back to its normal state, changing that potential energy into kinetic energy. Now, if we're talking about kinetic energy, and there's lots more example of kinetic energy than there is for potential energy, because again, kinetic energy is any form of energy where I have motion. So our first type would be radiant. And radiant energy is energy that is traveling through waves. Now, this includes our ultraviolet rays. So if we're looking at this, I have ultra and our infrared. And the part of light that we see, so this is the part of light that we see, this is visible light. Radiant energy encompasses all of this. Now, whenever we're talking about radiant energy that our eyes can perceive, we refer to that as luminous energy. And that's basically specifically the radiant energy for visible light. Our next form of kinetic energy is thermal energy. And thermal energy has to do with the agitation of particles in an object. So again, agitation, and a synonym for agitation would be movement. Of particles. Now, heat is the release of thermal energy. And that's actually how I perceive thermal energy. And when we're talking about the relationship between thermal energy, heat, and temperature, temperature is how I measure the thermal energy. So when I'm looking at temperature, I'm looking at how much the particles move. So things that have a high temperature have a high degree of particle agitation. Things that have a low temperature have a low degree of particle agitation. And heat is the release of this agitation. So now we're going to go on to our next form of kinetic energy, which is sound energy. And sound energy is basically vibrations moving through a medium. And most of the time, the medium is air. And the organ that we have in humans to perceive sound energy are our ears. So our ears, what happens is sound waves penetrate our ears. They cause a vibration of our eardrums, which then your auditory nerve senses those vibrations and then sends the messages to your brain. So when we're talking about sound energy, it's any vibrations. And anybody who has, put their headphones up to high or have been at a rock concert and have been close to speakers, not only can you hear the sound, but you can actually feel the vibrations because it is motion moving through a medium. And this is probably the one form of energy that we've been using a lot, and this is basically electrical energy. And electrical energy is energy through the movement of electrons. And now remember, when we're talking about electrical energy, we can have dynamic, where my electrons are in a circuit, or I can have static, where I have a charge imbalance. But whenever I have the movement of electrons, that would be electrical energy. Our last key form of kinetic energy is mechanical energy. And when we're talking about mechanical energy, we're talking about the movement of objects. Now, to be a little bit more specific, these objects tend to be man-made. So if we're looking at it, the car is moving, mechanical energy, the hammer is moving, mechanical energy. So whenever we're talking about an object in motion would be mechanical energy. So examples of objects that are moving, a windmill. Mechanical component, the actual windmill would be mechanical motion, and what's causing the windmill to move would be wind energy. If I'm looking at a hydroelectric dam, when I have water going through my my penstock, which is causing my turbine to turn, well, the actual movement of my turbine would be mechanical energy, and the initial form of energy before that would have been hydraulic energy, which is the last two things that we're actually going to be talking about. So again, here I have wind energy, and wind energy is due to the movement of air particles. And we have our trusty windmills, which basically capture the wind energy, convert it into mechanical energy, and then into electrical energy. And then last but not least, we have hydraulic. And hydraulic energy is energy that is due to the movement of water. And we tap hydraulic energy through the use of hydroelectric dams, through the use of underwater turbines, through the use of tidal dams. All of those tap the hydraulic energy, so the movement of water, and convert that into our other forms. Now, what's really, really important with energy is this idea of conservation of energy. And very similar to the law of conservation of mass, the law of conservation of energy is saying is that energy isn't created and it's not destroyed. It's only transferred or transformed. And if I have an isolated system, and the key word being isolated, that means that I've trapped all of my energy in my container and I have no escape, the system would remain constant. Now, this was proposed by Émilie de Châtelet in the 1700s, around very similar to the same time where we had the law of conservation of mass that was done also during that time. And this was actually inspired by Newton's Principia, where he developed his 3 laws of physics, which are now the cornerstones of Newtonian physics. And what's also really important is that the relationship between mass, so a relationship between mass and energy was really solidified by Einstein when he did his theory of general relativity, which was in the 1900s. And with general relativity, basically Einstein said that energy is related to mass, that the mass and the speed of light squared is equal to our energy. So basically saying that mass and energy are really in itself the same form, that they can transfer from one to another. So just like mass and matter is conserved, energy is also conserved. Now, what we actually have right here is a really cool diagram that's really showing the relationship between both potential and kinetic energy, and how the energy doesn't actually get destroyed in our scenario, it's just changing from one form. So if we're looking at right here, from the beginning, before the cannon explodes, I have potential energy right here. That I have my chemical energy, I have the potential for my projectile to fly. Once I have my cannon go boom, the projectile is starting to fly, and as it's moving, that potential energy is transforming into kinetic. And then once I get to the top of my parabola, at this moment, I'm not getting any higher, I'm not getting any lower. And at that exact moment, that split-second moment where my object is momentarily not moving, all of that kinetic energy is now changed into potential energy. And then gravity takes over, that potential energy is turning into kinetic, and then where I have impact, all of that kinetic energy transforms into heat and into sound and into my impact. So in this entire thing, I never lost energy. I never created energy. I just changed that energy from one form to another. So, and this is where we have this idea of energy transmission and energy transformation. When energy is being transmitted, I'm moving from one spot to another and the form is kept constant. So if we're looking at an electric circuit, wires have the function of energy transmission. Because their role is to basically allow electrons to travel from one part of the circuit to the other part of the circuit. And when we're talking about energy transformation, I'm changing forms of energy. So if I'm looking at an electric circuit, when I have a light bulb, what happens is I have electrical energy that changes into luminous energy. And also some of it changes to thermal energy. So whenever I have an energy transformation, I'm changing forms of energy. So let's look at a couple of examples of energy transmission and energy transformation. So if we have this right here, this is what we would see in a more planetary type scenario. And we have our cute little sun, and we have our Earth. And the key thing is that our sun basically produces energy in the sense that it has nuclear energy. And whenever it's producing solar flares, that nuclear energy going towards the Earth is being changed into radiant, because we can perceive sunlight, and it's being changed into thermal because we can perceive heat. So when I have my solar flares, I'm basically changing, so I'm having an energy transformation from nuclear to radiant and thermal. Now, if we're looking at something like an energy production scenario, so we have right here our hydroelectric dam, and we have our cute little city. Now, the first thing that happens is that I have an energy transformations for hydraulic, so the energy that's tapped into my water, to mechanical, because I'm having the turning of my turbine. And then as my turbine is turning, this mechanical energy is producing electric energy. So that is my first energy transformation. Then I have my power lines, and my power lines have the role of energy transfer, because what's entering the power line is electricity. What is exiting the power line is still electricity. So I'm not changing forms, I'm just bringing the electricity from one point to the other. Then once it gets to the city and it goes to all of my houses, that's where I again have another set of energy transformation. So my electrical energy is changing to thermal, changing to luminous, changing to sound, and so on and so forth. We also have another example right here where we have an energy production system just like before, but in this case it's not hydroelectric, it's coal. So my energy transformation would be chemical, because I'm burning coal, to mechanical, and then mechanical to electrical. So we have that transformation right here. And then my power lines, again, is energy transfer, where I'm transferring that electrical energy from my my coal power plant to my houses. And then once it gets to my houses, I have energy transformation to all of my other forms of energy that happens in my house. I hope this helps, and have a great day.